Before we start talking about compound interest, let's revisit what we looked at last spiral. Last spiral we talked about simple interest. And I mentioned that there are two ways to calculate interest. Simple interest was the first way, compound interest was the second way. So in spiral 1 we talked about simple interest. In spiral 2 we're going to talk about compound interest. So let's review what interest is. Interest is the cost of borrowing money. So there's kind of two examples I gave. It's when you borrow money, the bank lends you money, so you owe the bank interest. But when you put money in the bank, you lend money to the bank, so the bank owes you interest. So interest is an extra cost for borrowing money. And the way we calculated simple interest was this formula right here. I equals P times R times T. The amount of interest you earn is equal to the principal, which was the amount of money you invest, multiplied by the annual interest rate, multiplied by the number of years, the time. The amount of money you have is the principal plus any interest earned. We're going to look at the same idea of interest, but it's going to be calculated differently. So before moving on to this next lesson, take out this handout in your Spiral 2 notes. So it's lesson 206, compound interest. So whereas simple interest was calculated only on the principal amount of money, compound interest is calculated on top of interest already earned. And with simple interest, the amount of interest was calculated by taking the principal multiplied by the interest rate multiplied by the number of years. Compound interest is a little bit different. I'll illustrate it by giving this example. Let's say Bob borrows $100 and the interest rate is 5% per year. So if Bob doesn't pay back the $100 for another year, the amount of interest will be $5. So now he owes $105. So now if he still doesn't pay that money back for another year, he's going to earn interest on the $105. So now over the next year, he's going to owe $5.25 in interest. And that brings his total to $110.25. And now if he still doesn't pay back the money for another year, the interest is going to be calculated on top of this $110.25. So now he's going to earn $5.51 in interest for the next year, bringing his total to $115.76. So if Bob borrowed this original $100, that's his principal. If it was simple interest, he would be earning 5% interest on the loan each year. And that 5% would always be calculated on the principal, so that would mean he would be owing $5 in interest each year. So you would expect this amount of money owing to increase by $5 each year. But we don't see that. With compound interest, the first year he gains $5 in interest. The next year he gains $5.25 in interest. The next year he gains $5.51 in interest. So it grows and grows and grows. The interest is compounded. This just means that it's calculated on top of the interest already earned. So in the first year, Bob earned $5 in interest. Now we're taking that amount and calculating interest on top of that. Now he owes $110.25. Now we're calculating interest on top of that amount. So each year we're calculating the interest, but you'll notice this. Each year we're multiplying by the same amount. So each time we're multiplying by the same amount, I could simplify that and use an exponent, because exponents tell you how many times you're multiplying by the same number. And that's where the compound interest formula comes from. A equals P multiplied by 1 plus I to the exponent n. A and P, we've used those symbols before when we talked about simple interest. A is the amount of the investment or loan. P is the principal. That's the original amount of money borrowed or lent. But we use these other words too. So when I say amount, I can think of it as the future value. So if I put $100 into my account today, A would be the amount it's going to be in the future. That's the future value. P is the principal amount of money, or that's the amount that's in the account today when I invest the money. That's the present value. Now these other letters, I, that's a lowercase I, and N, those are new symbols. We haven't used those before. I is the interest rate per compounding period. And we're going to talk about that when we go through some examples. Hopefully it'll make a little more sense. N is the number of compounding periods. So when we talked about simple interest, we used R for the interest rate, the annual interest rate. I is different than that. We also, in simple interest, use T for the number of years or the time. N is similar, but it's not the same. So again, I'll illustrate these points when we do an example, and it'll make a little more sense. So this formula is useful when you're trying to calculate the future value or the amount of the investment after a certain amount of time. If I put $100 into my account today, what is it going to be worth several years from now? However, sometimes it's helpful to be able to figure out what the present value is. And that's where this formula comes in handy. P equals A times 1 plus I to the exponent negative n. So this would be useful if, say, I know that in 5 years from now, I want to have $5,000 in my account. So I know what my future value is going to be, or what I want it to be. So how much money do I need to put into my account today in order to be able to do that? So if you're using this formula, you're answering the question, how much am I going to have in my account at some future point in time? And if you're using this formula, you're calculating the present value, or how much do I need to put into my account now in order to have this amount later? Now I want to talk about compounding periods. So compounding periods just means how often the interest is being calculated in a year. And it might be useful to write some of this down. You can have annual compounding. That means it's compounded once a year. You can have semi-annually. That means twice a year. Quarterly would be 4 times a year. Monthly would be 12 times a year. Weekly, you're calculating the interest 52 times a year. Or even daily compounding, that would be 365 times a year the interest is being calculated. So the number of compounding periods in a year is useful information in order to figure out the values of I and the values of N. So for example, if my annual interest rate is 10%, but it's compounded semi-annually, that would mean that I have to divide that 10% per year into 2 pieces. So each piece would only be 5%. So my value of I, the interest rate per compounding period, would be 5%. Also, if I'm investing my money for 5 years, N is not 5 if it's semi-annual interest. N would be 10 because it's the number of compounding periods. If it's semi-annual compounding, that means it happens 2 times each year for the 5 years. That's a total of 10 times. But again, as we go through some examples, hopefully this will make a little bit more sense. So let's look at this first example. We're going to determine the amount and interest earned for each investment. Each investment has its own principal. It's invested for a certain number of years with a certain annual interest rate and a certain amount of compounding. So this is all compound interest. We're going to calculate the future amount, the future value, or the amount at the end of the time period. So since I'm calculating the future amount, I'm going to use my formula for calculating the future value. So in order to calculate that, I need to know the principal. I need to know the interest rate per compounding period, and I need to know the number of compounding periods. Well, the principal is this $1,500. That's the amount being invested. That's the starting amount. The interest rate is 5%. Anytime you see an interest rate, that's always the yearly or annual amount of interest. So it's 5% per year, and it's compounded annually. So that 5% gets divided through the year once. So the interest per compounding period is still 5%. N is the number of compounding periods. Well, if it's compounded once per year for 10 years, that's a total of 10 compounding periods. So I can plug in my numbers to my formula. I've got the present value, I've got the interest rate per compounding period, and I have the number of compounding periods up here. Now, I can just plug this straight into my calculator. If you have a calculator with a 2-line display, you can probably just type it in exactly as it looks. Use your exponent button to get your exponent. If you don't have such a nice calculator, you can do BEDMAS. So do the calculation inside the brackets first, get your answer, then give that answer an exponent of 10, get your new answer, and then multiply that by 1,500, and you should get $2,443.34. If you're not getting that answer, and you're not sure what's going wrong in your calculator, this is something that you should let me know about so I can help you. So if I invested $1,500 and then 10 years later, this is the amount of my investment, how much interest did I earn? Well, it's just the difference between the future value and the principal. So if I take my future value, subtract the principal, I'm left with the amount of interest, $943.34. Now I'm going to do the same thing for each of these investments. The real difference is, well, the numbers are different, but also the compounding is different. So whereas in the first example, the interest is compounded annually or once per year, in the second investment, it's compounded semi-annually or twice per year. So to calculate the future value, we're going to start with the same formula, but the numbers are different. So the principal is $2,000. Well, it's 8% interest, but it's compounded twice per year. So we need to divide this interest rate in 2. N is the number of compounding periods. So for 5 years, compounded twice per year, that's 5 times 2, that's 10 compounding periods total. So when I plug in my numbers, I have to remember to divide my interest rate by the number of compounding periods per year. And I need to remember to multiply my number of years by the number of compounding periods per year. And then I type this into my calculator the same way. So I can just go straight 2,000 bracket 1 plus 0.08 divided by 2 bracket exponent 10. And if you don't get the same answer as me when you try it on your own, again, you got to let me know so I can figure out what the issue is with how you're putting it in your calculator. Regardless, what's the interest? Well, we started with $2,000. We ended with $2,960.49. So the interest is just the difference between those. So with a $2,000 investment, you're earning $960.49 in interest over the span of 5 years. The other two investments are pretty much the same. It's just the compounding is different. So here we have quarterly, that means 4 times per year. Here we have monthly, that means 12 times per year. So why don't you pause the video and try to calculate the future value and the amount of interest for each of these investments, and then when you're done, you can continue the video and check your work. So once you do all the work, you should end up with these answers here. Make sure you're dividing your interest rate by the number of compounding periods per year, and you're multiplying the number of years by the compounding per year. If you're having troubles with those, this is something you need to ask me about so that I can help. Okay, next example, Mr. Fisher wanted to save some money, so he invested $6,000 into a 90-day guaranteed investment, that's called a GIC, at 2.5% interest compounded monthly. How much money will he have when the investment matures after 90 days? Okay, so what's the question asking? It's asking, how much money will he have? That's the future value. That's what we're trying to find. So that tells us which formula to use. Okay, now we need to plug in our numbers. So we need the principal. That's the starting amount of money, or the amount invested. That's right there, $6,000. Interest rate per compounding period. Well, the annual interest rate is 2.5% interest. So that's 0.025. We have to divide it by the compounding per year. So it's compounded monthly, so we'll have to divide by 12. So that'll get us I. N is the number of compounding periods. This is tricky in this question because it's compounded monthly. So N is the number of months. Okay, well, it's 90 days. So we're going to approximate here. If each month is approximately 30 days, that would make this 3 months. So we're going to say N is 3. There's 3 compounding periods in this question. So we're plugging our numbers. 6,000 is the principal, 0.025 is the annual interest rate. We're dividing by 12 because it's compounded monthly, and N is the number of compounding periods. Well, it's 3 months, so it's 3 compounding periods. Plug your numbers into your calculator, and you should get $6,037.58. Okay, next question. How much should you invest today at 8% compounded annually in order to have $2,000 in 5 years? So the question's asking, how much should you invest today? Well, that's the present value, so that's the formula we're going to use. A is the amount we want to have in the future. That's our future value, $2,000. I is the interest rate per compounding period. Well, it's 8%. It's compounded annually, so once a year, so it doesn't change. It's still 8%. In 5 years, well, it's compounded once a year for 5 years. That's 5 compounding periods. So when you do the math, you should get $1,361.17. That's the amount you should invest today so that you can have $2,000 in 5 years. Things to watch out for, this negative sign right here. Don't forget the negative exponent when you're finding the present value. Next example, John has a loan for $5,000 that is due in 4 years. He wants to pay off his debt early. The creditor is willing to discount the loan at an interest rate of 8% per year, compounded semi-annually. How much would the creditor be willing to accept today? There's that key word again, today. That means we're looking at a present value problem. So we're going to use our formula to calculate present value. Interest is 8% per year, but it's compounded semi-annually. So we need to divide the 8% by 2. Also, 4 years with semi-annual interest, that's a total of 8 compounding periods. So once you plug in your numbers, you should get $3,653.45. That's how much the creditor should be willing to accept today in order to pay off the $5,000 due in 4 years. When you flip the page over, I want to just go through a little exercise here comparing simple interest with compound interest. So we're going to invest $100 with simple interest, 2% simple interest, or 2% interest compounded annually. So we're going to compare simple interest with compound interest using the same principle of $100. Now this formula here for simple interest, well, the amount is going to be the principal plus interest, and interest was P times R times T. So that's where this comes from. So I've got my formula for the amount of simple interest, and I have the formula for the amount with compound interest. We're going to fill in a table of values, make a graph, and compare what the graphs look like. So you can spend a few minutes here just figuring that out, and then you can check your answers with what I have. So when I calculate my values, this is what I get. You can see with simple interest, it's increasing by a constant amount, which gives us a linear graph. With compound interest, we're not increasing by a consistent, constant amount. It increases by more and more and more and more and more every time. This gives us a curve. The amount increases faster and faster and faster. That's an exponential graph. So if you're comparing simple interest with compound interest, this is the one that lenders like to use because the interest grows faster. So when you have a credit card and you owe a balance on your credit card, this is the kind of interest they use. It grows faster and faster and faster. So the longer it takes you to pay back your credit card, the more and more and more interest it's going to accumulate.